Now for the fun stuff. So 4.6, Part 2, Examples 1 and 2. I know there's 8 of them. I'm just going to split it into videos so this way if you need to replay part of it, you won't have such a long video to have to scan through to get to the part you need. All right, so number 1 starts out with y equals the inverse sine of negative 1/2. Well, remember, this is the same thing. We got the inverse by switching the x and y. So if I want to undo it, I'm going to switch it back. So this just means that the negative 1/2 is equal to sine of y. So this means that we're looking for sine of what value will equal negative 1/2. Well, first remember it told us that the inverse sine, the answer is going to be between negative pi over 2 and positive pi over 2. So where is that at first? So we know pi over 2 is up here, hopefully. Where's negative pi over 2 on our unit circle? Well, it's down here at the bottom. So if I'm looking from negative pi over 2 to positive pi over 2, I'm really looking in quadrants 1 and 4. The only problem is if my answer is in quadrant 4, using our unit circle, it's going to be an answer that is not between negative pi over 2 and positive pi over 2. It'll have the same value, but it won't be an angle that fits within that range there. So what we're going to have to do is if we get a quadrant 4 answer, we're just going to find its coterminal angle by subtracting 2 pi, and that would put us between negative pi over 2 and pi over 2. All right, so back to this. So we're looking for negative 1/2 is equal to sine of y, meaning sine of what number, what angle is going to give us negative 1/2. And we're only looking in quadrants 1 and 4. Well, we can bring that down even further because we know that sine is negative here. And that's only going to happen in which quadrant? Quadrant 4. So we're looking in quadrant 4, and we're looking for where sine is a negative 1/2. Well, remember, sine is y over r, and on our unit circle, r is 1. So y over 1 is just y. So we're really looking for the y value in quadrant 4 that is negative 1/2. And so you're going to find that, and so you're going to tell me that it's at, hopefully anyways, 11 pi over 6. But you're in the right location, but 11 pi over 6 is not between negative pi over 2 and pi over 2. So what we're going to have to do is we're going to find its coterminal angle by subtracting a complete circle. So we subtract 2 pi, and that gives us negative pi over 6, which is in the same location, and it is an angle that's between negative pi over 2 and pi over 2. All right, so moving on to number 2. Number 2 tells us y equals the inverse sine of 5. So what this means is 5 is equal to sine of y. When I switch my x and y, I do the inverse, and the inverse of an inverse is the original. All right, so remember, we're looking for inverse sine, so we're only looking in quadrants 1 and quadrant 4. Sine is positive here because it's a positive 5, and that's only going to happen then in quadrant 1. So if you look in quadrant 1, remember the sine is y over r. On my unit circle, r is 1, so we're just looking for the y value that's 5. And you don't see it, do you? Because it's not there. So there's two things that's happening here. Either one, it belongs to an angle that's not written on my unit circle, so we'd have to use our calculator. Or 2, this is going to be undefined because that value will never exist. So let's go back and check real quick. Remember, the domain for inverse sine tells us it has to be between negative 1 and positive 1. Is 5 between them? It is not. Therefore, that means that this solution is going to be undefined. If it had been a number, let's say 0.349, that would be between negative 1 and positive 1, and therefore that would mean we would really have to use our calculator to find this because we don't have it written on our unit circle. But 5 is not within that domain, therefore it is undefined.